Right, ladies and gentlemen, hello and welcome back once again to the Briefing Room series. Yours truly, Eric Kavanagh, is here, and I can't go through a show without promoting the world's first made-for-TV webinar series. It's called Future Proof. Check your local listings. We're in Washington, D.C., Atlanta, Detroit, out there in Silicon Valley and Pacifica, and we want to know what you want to know, so send me an email, info@dmradio.biz. Let's dive right in. Enhancing AI accuracy with Graph RAG. Here are our speakers today. Yours truly there, of course. Philip Rathle, CTO of Neo4j, Jon Brewton, CEO and co-founder of data², and Daniel Bukowski, CTO of data². Quick introductions. Philip Rathle, I've known this man for a number of years, since way back in the Embarcadero days. He's been in this business for a long, long time. Now he's working in Graph. Tell us two seconds about yourself, Philip.
Yeah, I've been doing databases for a long, long time, like multiple decades. Fell in love with graphs when I discovered them about over a decade ago now. And it's just been this journey of slowly but surely, industry after industry, use case after use case, realizing that graphs are good for lots of things. Until very recently, GenAI showed up, and it turns out knowledge graphs, graph databases play a really important role there. So looking forward to speaking all about that today.
Yeah, and Jon Brewton, CEO and co-founder of data², former military guy. Tell us a bit about yourself.
Yeah, Jon Brewton. I'm a oil and gas and military and defense guy for my entire life, so that really makes up who I am. Our company, data² was founded roughly 19 months ago, and we started our company to meet a vision of creating and discovering a better way to do analytics. And one of the best ways that we found was to tie graphs to how we sort of see the world, and that led us to Neo4j and our partnership there. But we're really building an end-to-end platform that sits on top of, next to, or alongside a lot of other systems. And we built this platform, the review platform, to empower analysts and decision makers to analyze massive amounts of differentiated data, so multimodal data at its core, and help improve their strategic decision making, their tactical decision making. In concept, we're a lot like Palantir or C3 AI or Scale AI, but we're different in one area that sort of makes us very different. We combine graph data models, traditional data science, graph data science to deliver fully explainable, fully reliable, fully transparent, fully trustworthy outcomes. So with our system, we've been in key deployments in the government and in the commercial space in the oil and gas industry. And ultimately, we're looking to share our story with some people and tell you that there is a better way to do analytics today. We can reduce hallucinations to nothing, and we can give you real explainability in these models at scale.
And that's the key, folks. We'll talk about that through the course of the next hour. Daniel Bukowski, last but not least, tell us a bit about yourself from Neo4j to data². So you've
Ab-
worked with both these companies.
Absolutely. And in fact, I've been working with graphs for about 20 years. I started as an Intel analyst in government 20 years ago, building them by hand. And then when the Panama Papers were published, using a Neo4j graph database, that was my motivation to move out of kind of intelligence and forensic accounting, which is where I started, into data science, and especially graph data science, or network analysis, as we called it, about 10 years ago. Spent a couple of years at some of the big tech firms using graphs for cybersecurity, incident response, that type of work. And then, as you mentioned, spent the last few years working at Neo4j, really focused on graph data science, and as ChatGPT was released, all of the integrations with GenAI. A
Well,
few
that's
months
some
ago,
pretty.
I met
Go ahead.
Jon and decided to make the leap to data² because I was really excited about the platform that we were building. But even though I'm with data², we are, as evidenced by our presentation today, we're really close partners with Neo4j. We're building on the foundation of a Neo4j knowledge graph, and really thrilled to keep moving this partnership forward.
Well, we're going to do that right now. So there's the Tower of Babel. You've all probably recognized this. I had an epiphany a couple weeks ago, and it's been blowing my mind ever since. I've been in this industry for 25 years, really over 30 years if you go back to the early dot-com days, or like back into the 1990s. And I've been fascinated by technology. Well, if you go back to the earliest days of programming, of compute, of information systems, What's the foundation? Well, of course, it's the database. And then you have applications that sit on top of the database. You have the network to get access to things. You have security and other stuff like that. But mostly it's the database and the applications. Well, over the past half century, we have worked, and I mean we by many, many, many companies. There are like 400 databases now that you can use, or something more than that even. And we've worked to make them faster, more reliable, more durable, more performant. We've focused on greater concurrency of users, things of this nature in database analytics, all kind of stuff we've been focused on building over the last half century. But one thing has always been table stakes, and that's accuracy. We've never sacrificed accuracy. Whatever you put in the database is what you got out. It's a question of how fast you got it out, how easily you got it out, how you can get out and join with other things, for example, joins and all that kind of stuff. But accuracy has always been 100%. It's just assumed, of course, it's going to be accurate. It's table stakes. And then what happens? A couple years ago, Gen AI comes along, and it's like the Tower of Babel coming crashing down. We take accuracy and throw it right out the window because these are probabilistic systems. You can't crunch letters, you can't crunch images, but you can crunch numbers. And so these large language models, what do? You take text, you train your model by basically updating weights and biases, billions of them, these parameters, billions of them, weights and biases on vectors, basically. So cat becomes a vector, dog becomes a vector in this sort of landscape of vectors. And then upon a prompt, it converts the vectors back to text or imagery. And here you go. This was done using Gen AI, using Gemini, as a matter of fact, from Google. My point is that all of a sudden, it's like throwing a noise filter on the end of the workflow. We worked so hard for 50 years to get it just right, and now let's throw that all out the window with Gen AI. That's kind of what's happened, and that's crazy. So, and I was talking to a gentleman just a moment ago on a separate show, and he was saying, yeah, these big guys, they don't even know how to fix this problem. It is by nature generative AI. It's as the top go-to-market guy for OpenAI said to me on Twitter a couple of years ago, remember, these hallucinations are not a bug, they're a feature. It's generative in nature. That's what the guy's told me himself. So I point that out because it's kind of crazy. And we have to find a way to ground these things. And vectors alone aren't going to do it for you. Vectors, remember, are just representations. It's a lossy process to go from text to vectors, then from vectors back to text. It's always going to be a lossy process. So how do you ground it? Well, of course, there are vector databases. You can have a RAG model, retrieval-augmented generation. We're going to talk about that. But it's not going to get you there. Even some of the best ones are like maybe up to 85%. Well, what part of your business can be wrong 15% of the time? I'll tell you what part, not much at all. All right, so with that, I'm going to hand it off to, I believe, Philip Rathle. I'm going to stop sharing. And Philip, why don't you go ahead and share and take it away? And folks, don't be shy. Send your questions in at any time. We want the hardest questions you can give these guys. So go ahead, Philip.
All right, excellent. So yeah, we've got a fun agenda for you today. We're gonna alternate between just concepts, build on the concepts, and then jump in with lots of demos interleaved in between. So let's talk about knowledge graphs first and what those are, and then that becomes a foundation for, well, how do they help with Gen AI? And my teaser here is knowledge graphs showed up on Gartner's list of 30 emerging technologies that will guide your business decisions in their impact radar for 2024. I don't know if they've published the 2025 one yet, but you'll see there are two things that they're saying are important now, and that is Gen AI, no surprise there, and knowledge graphs. So pretty important technology. And if you are questioning, how you explain to your boss spending time with us today, here's a good excuse. So what's a graph and where do graphs show up? And let me start with some examples. Here's a graph of commerce transactions, and you can picture all the kinds of use cases that might involve this kind of data set. We have a customer buying a product, another customer buys the same product, customer is at a location, gets delivered, the product has different components. This is a very simplified version, but you get the idea. Another kind of graph that you have is in product targeting. So here I have a set of products. They're grouped into different categories, and each one has a SKU, and they're tied into promotions, and those promotions actually oftentimes have a deep, deep tree of promotions by category and time and location and things being bought together and so on and so forth. Another example you see is with customer engagement. So something starts out as a lead, and then it becomes a contact, and then it moves through a funnel. And along the way, that funnel isn't just a strict top-down, straightforward kind of thing. You've got all this activity, and it shows up naturally as a graph. And then digital twin is another one, as products are composed of, you have product digital twins, city digital twins, building digital twins, and all these things have a shared characteristic of having components and subcomponents and subcomponents and subcomponents. And these nicely show up as hierarchies or graphs. In fact, many of the top airlines and car companies use Neo4j to store their entire product. So there's a digital twin of the logical architecture for a given airplane, and then each physical airplane out in the real world has a corresponding physical graph, which is its digital twin, which they can use for documentation, part replacements, impact analysis, design, and so on. So these are examples of the many kinds of data sets that you have showing up due to activity that inherently is complex, connected, dynamic. And if I boil it all up, you'll see two kinds of shapes here. One is networks. So a lot of your world as a business, as governmental organization, et cetera, shows up as networks. So here are some examples: computer networks, social networks, communication networks, biological, ecological, payment networks, transportation networks. You've seen all of these. Or hierarchies. So what do you mean by hierarchy? Org chart is a common one. Supply chain, bill of materials, I mentioned, like product and airplane graphs. Promotions, asset ownership, if I want to do ultimate beneficial owner, and so on. And now if you generalize networks and hierarchies, you could say those are both different kinds of graphs. Oftentimes, you want to be able to attach these things to each other as well, and derive additional value by just connecting different parts. And you've all seen this and probably lived this many, many times as I have. The way we most commonly store networks and hierarchies is in a relational database, and it ends up looking like this. And it often takes a long time to get from your logical or conceptual design into something like this and to query it. And what a knowledge graph is and a graph database is simply a different abstraction for storing the same data, but not as tables, but rather as a graph. Turns out there's an ISO standard that came out last year on this called GQL. GQL is the language that is now a sibling language to SQL. And it's the first time in close to 40 years that the International Centers Organization has deemed a data model and a language to go with it important enough to create an international standard. So this is just a way of storing data that's aligned with how we conceptualize the world. So those of you with a data modeling background, the conceptual, logical, physical model all look pretty much aligned. And one of the key things that this offers is built-in agility, because your schema is flexible. You can just add data to your graph and not have to model it ahead of time and remodel it and go through schema migrations. And in a world of AI where you've got infinite choice of the kinds of data you can bring in, and data business is fast moving, which means your data and database needs to be fast moving, and you need to be able to stitch all these things together. It turns out the graph is a really good representation for this, which is what today is about. What can you do once your data is in a graph? You can answer questions like what's important, what's unusual, what's next. One way I like to tell this is that the shape of the data tells a story, the topology tells a story, and this is another kind of insight that you can lever into your application that you're not getting if you're just looking at data from a store and retrieve perspective. I won't go through all of these, but suffice to say that there are lots of different uses of graphs across different domains. You'll see some examples. And that this is a trusted and true technology foundation that you can use. You won't be the first by any means to leverage it. And then I'll just close by pointing out some areas inside of the enterprise that are graphs. So you have your graph of employees and a bunch of use cases that are tacked onto that, where if you represent your employees as a graph, you can do better talent, learning and development, career management, skills management. We're actually working with one of the world's largest employers to create a GenAI based talent mobility graph of help me find my next role inside the company. What's the best path? Network and security. This is where Daniel came out of a while back. And there's a great saying coined by someone at Microsoft saying that attackers think in graphs, and if defenders think in tables, then they're pretty much sunk. Like you're playing checkers versus chess. Suppliers and partners, and I won't go through all the use cases. You can imagine all these process, product, and so these are all real world examples of individual data sets across your company that are graphs where you can add a lot of value. And today is about Gen AI. There's an opportunity to up level every single one of these using Gen AI with knowledge graphs. And last but not least, customer. And the other notable thing, and this is a segue into Klarna, which we'll talk about later, who recently revealed that their Gen AI application, which has allowed them to, among other things, unplug 1,200 SaaS apps and create all kinds of new top line value, is about repatriating and connecting all the data they have in their enterprise into a connected knowledge graph. So all these things connect to one another. And the beautiful thing about graphs and graph databases is you don't need to do what we used to do with data warehouses and data lakes, which is let's boil the ocean, let's bring all the data in the known universe in and then try to figure out what to do with it. You can actually flip it around and say, I'm going to start with one of these, knowing that I'm building towards this. So let me hand the mic over and we're going to do our first demo.
Yep. Just one quick one before Dan jumps in. I think the last thing that you talked about there, Philip, is so important is how do you use this stuff to create value at the end of the day? And I think a lot of people are spending time looking at sort of the shiny objects here, which is neat. We can generate text, but how do we convert that technology and the use of it in combination with graphs to something that creates value? And we'll go through it a little bit later, but like Klarna, working in the oil and gas industry, we've been able to define a couple of key use cases. And it all really starts at the end of the day with connecting information. And whenever we're able to connect information, we can get beyond what a sort of traditional approach is. And Eric talked about this earlier, a sort of a vector-based method, right? And we're essentially looking at flattened relationships that are complex in how we connect them, but not persistent in nature, while a graph is very tangible in nature. So that allows us to sort of focus on the foundations. And when we can distill that down to problem spaces, we can really start to evaluate the pieces of information that are required to answer critical questions within a given problem space. Mm-hmm. We understand those things and we can start to build persistent graph objects around them. And then we can understand transactionally how information flows through the system and what is relevant to that. And as long as we can do that, we can start to develop this sort of unified knowledge stack. And it's connecting previously siloed information without having to data lake it. We can actually leave it where it is and create persistent connections to it and start to do tactical extractions from existing repositories of information, all in service of trying to optimize the value chain. And then in the oil and gas space, like I said, we'll talk about a couple of things, but we've been able to generate and unearth a lot of value very quickly by applying graphs and these techniques to commercial use cases. And Dan will give you a demonstration of what that looks like. And then we'll get into the details from an oil and gas side later. But I just wanted to say the Klarna example is incredible. And there's another set of incredible examples that we're going to stumble upon and unearth over the course of the next year that are going to be just as meaningful. And so we're really looking forward to the conversation today. Dan, sorry, turn it over to you, sir.
Yeah, absolutely. Happy to do that. And what we wanted to do is just jump in real quickly and just show what this would look like using data²'s review platform combined with the power of the Neo4j graph database. And so let me share my screen really quick. And is everything coming through?
Yep.
All right. So at data², we're building the review platform. And what this is it really takes the Neo4j database and turns it into a production-ready, enterprise-grade application. And our platform does three things to not just help you solve those problems, a lot of like what Philip was talking about, but do so as quickly as possible. Our platform will help you get your data from the source into Neo4j label property graph. So whether you have structured or unstructured data, bring that data into the graph database. From there, you can then interact with the data using dashboards and interactive visualizations and kind of analyze your data as a graph, which standalone is an incredibly powerful capability. Something that, I know Philip knows well and I know well. It was a lot of our customers were working towards that when I was at Neo4j. But then we also add on the reasoner, which is actually what I'm showing here, which is that graph RAG. It's using the graph to inform a language model to enable accurate and highly transparent interactions with the data. And so the scenario we have here is one that's very top of mind right now. Supply chain, specifically secure supply chain. This is a synthetic data set that we created for this demo. And you can think about it from the perspective of whether you could be a program manager in the military or working at a major defense contractor to build a new drone, a new UAV. And the scenario we have is we heard that there was a malware attack on one of our suppliers. And so what I was able to do using the data² reasoner is just ask, which of my vendors or shipments or products were affected by this malware attack? This is a small data set, but you could think about it. It could be a global supply chain with hundreds of suppliers and thousands of components. When I asked the reasoner this question, it gives me, it immediately finds who was the vendor who was impacted, and then what were the shipments that we know were impacted. And what you see right here inside these parentheses is this is actually the citation back to the graph. And you will see this scattered throughout the answer. We've designed the reasoner so that everything it brings back is cited in a node or a relationship back in the knowledge graph. And it's very clearly cited so you have that transparency. So just like, I started my career as an Intel analyst, we have our bottom line up front right here. And then the reasoner will go through and give a more detailed answer around who was the vendor, what are the specific shipments, and then what were the specific products that were affected. Let me go over here. And then all throughout we have our citations, again, references that I could take back. This is an ID of a node in the graph. So I know where this answer came from. And that's what we see is so important with our customers, especially in energy, especially in defense. They want to make sure that everything is fully transparent and fully cited back to the source data and to the original conversation. You just don't get that with an out-of-the-box language model. So I'm going to step back a little bit and say, okay, how did we get here in the response? So most of the data or most of the graphs that I've built, just throughout my career started from structured data. And if I'm a supply chain officer or a program manager, I probably have a lot of tables or a lot of spreadsheets where I have my vendor and product information. That's actually what we have over here because a lot of people still need to have their data available in its native form. So if I go over here in the platform, I can see I have all of my suppliers. This would be a table in a relational database. I have all of my products and kind of components and subcomponents that are rolling up to this finished product. I have my contracts, which is a mix of structured and unstructured data. So who's contracted to deliver what? What are the terms? What are the value of those contracts? I have all of my shipments, what's in flight, what's in transit, what's delivered, what's delayed. And then we're also bringing in open source information. What are events? There's new sanctions, there's new export restrictions. We might have tariffs. Who would have thought? All of these things are going to affect a global supply chain. And then because this is a government program, we might also have intelligence, or if you're a commercial organization, this could be cyber threat intelligence from a kind of a feed provider. So we're bringing in all of this structured and unstructured information and turning it into a graph. And so this is kind of the starting point of taking your data from where it's at and getting it into that graph. But what does that look like? So the next thing we have as part of the platform are the key graphs. And this is a series of dashboards that we've built to show just different kind of limited views, because you might not need a fully interactive experience with the graph. You might just need some quick just dashboards like you would have from any other platform. And so, what we see right here is actually the graph data model. It's what does my data look like as an actual graph? And we're using part of the Neo4j platform here where you can see I have organizations. These are my suppliers. I have the shipments. I have the intelligence. I have the products and components. And then this is just giving you an overview of what is actually in this database, what is in my graph, the nodes, the node labels, and then what are some of the key patterns I should be aware of. An organization produces a product, a supplier produces a component, these types of things. But then we can start going a little bit further and really show the power of viewing your data as a graph rather than in a spreadsheet. So if I click over here, I actually have, and let me get zoom out of the way. I actually have my entire component graph. This is what Philip was talking about before, where you might have all these different components that roll up in a supply chain to a final product. I'm seeing that here. Obviously, this is a very small, small demo data set, but I have my drone in the middle here, and I can start to see what are all the different components that come together to make this finished product. And obviously, there's maybe 24 here on the screen. This could easily be 10,000 or more components for a sophisticated drone. And I can start to see, what exactly, what is each piece of the component coming together, and what, subcomponents feed larger components and make up this actual product. Now, assuming we have a really large supply chain, I might just want to look at a specific piece of this. So I can actually zoom into just a small piece of the product if I want to go a little bit deeper. Again, these are just small views into the data. We can see a 360-degree view of our suppliers. Again, I have one of my prime suppliers here, and I can start to see what are the products they're building, or what contracts do we have, what intelligence, what shipments do we have about them. Very useful when I just need to get into a specific part of a large, sprawling global supply chain. We can do the same with shipments. And then also we brought in our intelligence. And so again, I have a cyber threat bulletin here. If I want to see what's going on, I'll zoom in a little bit here if I can. I actually have, this is a threat advisory about some malware that we were worried about in our supply chain. That's exactly what happened and actually disrupted several shipments from a key logistics provider.
Wow.
So let me zoom out here. It's actually not cooperating with me. I'm a little stuck on my screen right here.
That's quite all right. That's quite all right. I mean,
Yeah.
This is absolutely fascinating. And what I love about this is your ability to drill left, right, up,
Yeah.
down, back, sideways, and just move all through this because you've synthesized a whole array of information systems. I mean, you think about it, we came up with data warehousing because we realized that you couldn't really query operational systems very well. It's not what they were designed to do, but it's all structured data. Well,
Yeah.
all the context is in the unstructured data, and unstructured data doesn't necessarily fit into relational tables. And I think that's
Yeah.
the key. So now what you're doing is you're fusing together, you're synthesizing this array of information tools to give a truly strategic bird's eye view of everything that's happening, right, Daniel?
Exactly. And that's what, those were just some dashboards. If I actually want to dig into the data even more, this is where we can leverage Neo4j Bloom as part of the explore part of our, the review platform. And actually, if I wanted to see, let's see, I'm going to go to, where is contains? Here we go.
Right.
I can actually go from the threat intelligence event to all of the delayed shipments and actually see what components were in those specific shipments. And so very quickly, if you've used any cyber intelligence tools where the concept of pivoting through a graph, I can pivot and pivot and pivot from the cyber incident to a shipment to a specific component that was affected, and keep going to the producers, the suppliers, and really expand that graph starting from one piece of information we're already seeing how many different things are connected together, which is completely different. If I'm going to jump back here to our spreadsheets, I can't get that information by looking at a spreadsheet right here. It just doesn't show the connections among the data. And then the last thing we want to show is to tie it back to the reasoner in the GenAI component. It's not just what happened, what's in the graph, historically, but it's also looking forward. So this happened. How do I strengthen my supply chain so it's not susceptible to the malware attacks? And again, we get a fully cited answer where it's going back to the data in the graph, and it's going to walk through some very strong best practices. Do we have cybersecurity measures for things like our freight forwarding system? Are we actually tracking compliance with audits to our supply chain? Because a breach in one small supplier could ripple throughout our network. Do we have transparency in our logistics? That's what graphs are great for. That's what Philip was showing earlier. Supply chain, bill of materials. You can see how things are connected and how they roll up together. And then even sharing threat intelligence. Are we making sure that our suppliers are getting the information they need to be aware and to make sure that they have the proper defenses in place? And to tie it all together, we have all of the citations back here in the graph. I could take these back to the graph, pull up these exact nodes, and see exactly what's going on. So that's really at a high level what we can do, what we're building for with the Review platform on top of the really strong foundation of a Neo4j graph database.
Wow. So you're basically building out bespoke, highly detailed, citation-filled reports about what's actually happening on demand. Is that about right?
Exactly. And
Yes.
yeah, go ahead, John.
Oh no, that's it in a nutshell. You probably nailed it. I don't know that I could have said it better myself.
Yep.
Wow.
So I'll go ahead.
Yeah,
I'll
I
go
think
I
ahead.
think just one note here. One of the things that we focused on from a UI perspective before we pivot to the next
Yeah.
piece of this conversation was making sure that we could represent the world with how people see it today. 99% of the people in the world, 99.9% of the people in the world probably see the world in rows and columns. That's what we see. Every relational database, every Excel spreadsheet, everything is rows and columns. And so, not to upset the apple cart too much, we wanted to make sure that whenever we put this information back in front of the people that have provided it to us, it's in its native format. You can see it in rows and columns. You can engage with it in rows and columns. It's not something new that you have to learn as much as a window into your data in a native format. Now, the graph is still functioning in the background, and that's the thing that we're reasoning to and through at all points in time. And to Dan's point, you just saw you can engage with the graph, but it's making it easy on the people that are going to be receiving these solutions so that they don't have to relearn how to see the world. Just present it in its native format so that people can be comfortable with it and engage with it in the ways that they do today, but get better outcomes, better results, and more transparency.
wow. That's
Yeah,
very
it's there. It's an incredibly powerful foundation, but there's going to be parts of your work where you might want to engage with the graph, but there might be parts of your work where, I started my career as an accountant, and so I love spreadsheets as much as everyone. There might be times where it's more intuitive to engage with the data, kind of with something that's a little bit more familiar, but still having the power of the graph behind the scenes. And that's what we're aiming to provide, both of those options for, to make sure that the data is available. And at the end of the day, this kind of ties back to what John and Philip said before. We're solving important problems and helping to generate value. It can be as simple as make me money, save me money, but it can also be make my job easier, make my job faster. You're running a query, running a cybersecurity query on a connected data in a Neo4j database is a lot different than the 8-hour, 8-table join queries I was running at one of the big tech firms when we would have an incident. It's the little things like that that can make your work that much more effective, that much more faster. And we really want to make sure these capabilities are available to the high reliability industries we're going after.
well, and you have such rich explanations of different component parts, so you can see it as a graph. To your point, you can then see it as rows and columns. You can get detailed text explanations for what's happening, and you can follow that graph through its various component parts to get to the meat that you were looking for, which is, hey, what's the impact of this malware attack in our supply chain? Which, let's face it, is a very, very complex
Yeah.
structure, and relational databases don't do too well with supply chain, right?
Yeah.
That's right.
Exactly. And you think about it, this demo showed it was a logistics and supply chain, it was finances and contracts, it was cybersecurity. These are typically different departments in an organization and probably different data systems. One of the great benefits of graphs is that it can bring all the structured, unstructured, different types of data together in a single view where it's, you have an entity resolved view. So you have one version of everything, and I can see exactly how all of these pieces fit together. One of the best uses for graphs is to connect data across silos and across systems in a large organization.
Right.
And that's kind of
Right.
without emphasis, that really wasn't the goal of the demo, but that is kind of one of the subtle capabilities or demonstrations in the demo, is that we brought a lot of this data together that would often be siloed in different parts of the organization.
That's right. And you think about the cost, the time, the difficulty, the challenge of doing these sort of joins and complex queries in a relational database. And it's just, it takes time, it takes effort. This is a much swifter way of getting to the answers that you want, and doing so in whatever trajectory makes sense for the user. And the fact that it's bringing together, it's synthesizing all this stuff from different systems, to me, that is really, really, really important. Because, and I try to say this at the top of the hour, for data warehousing, we stripped out all the context to get little bits of information back in the day through thin wires to slow processors from expensive storage. Well, now the wires are fat, the processors are faster, we have GPUs, the storage is cheap. Like, all those constraints are out the window, and we're in a whole new world now, right?
Hmm.
No,
Wow.
exactly. And that's where, you have the compute, you have the data, but just because you have so much of this data doesn't mean it's connected, doesn't mean it's available. And that really also gets into, some of the benefits of using a graph to ground these language models. And I know that's something like Neo, Philip, that Neo's really been leading on, for what, almost 2 years. I think we had the event in Malmo, what, 2.5 years ago, when, ChatGPT came out, where graphs are also key to bringing all this data together, because you can't just throw all the data at a language model and hope it's going to figure it out.
Right.
Like, you actually you need that connective tissue, as John talks about quite a bit, to show it's not just the pieces, but it's how they fit together.
Yeah. And I think, Philip, we want to get another presentation
Yeah.
from you. We do have a whole bunch of questions from the audience. Let me just throw one in to spice things up. And maybe I'll throw this over to Dan. It's a great question. Can we study temporal dynamics, for example, trends of the supply chains in some way? John, why don't you go ahead and answer that?
Oh, yeah. Look, I think what we do conceptually is try to incorporate every element of definable structure for anything from a metadata and a semantics perspective when we actually enrich and embed these models. So we start with trying to define the who's, the what's, the when's, the where's, so that we can ascertain very easily and through natural language the whys and the hows. And to be able to do that with a level of effectiveness that is required by high reliability industry, we need to ensure that we can define the starts and the stops, the whens and the wheres and hows as a function of that temporal sort of piece of the puzzle. So if we can geolocate something, we know when it started, when it stopped, how it's connected to everything else in the system. We can start to use those temporal pieces of the puzzle
That's
in
great.
decisioning. And it's really, really important to structure your environments this way. It just buys you so much fidelity and understanding.
Yeah. That is really impressive. Here's another question. One of our attendees asks, most of the analysis in business starts with analysis at aggregate data in a region and drills down to a specific product, customer, or zip code for KPIs like sales cost, et cetera. Is the graph database the right construct for such analysis? Well, it's a big component part, right?
Absolutely. And there's, what I've talked about a lot before, and I know this is, something that, a lot of my, friends and colleagues at Neo talk about, is graphs are additive. And so, there's times it can replace a database, but there's a lot of times where it's augmenting an existing database. I started my career as an accountant, and so if you just want to add up a column of numbers, a spreadsheet's great for that. I'm not trying to replace that. But if I want to really dig into and see, kind of the component pieces and where the expenses are, or, where is where is money being spent, where are resources being spent, I can distill that and then start to look at, okay, at a large scale, here's all of the expenses, here's all the revenue that I have. But then if I want to dig into, more precise, or more granular areas, that's where the graph could come in to show where the connections are between, it's not just what's happening in aggregate, but what's going on beneath the surface, where are the trends in our data, where are the connections in our data that might lead to that larger aggregate. And so in that case, I would say, yes, they're very applicable, but it's additive to what you have. It's complementary. And that's really a lot of graph use cases will complement some existing, maybe larger enterprise systems, because you don't need all of your data in the graph. You want to have the data in the graph that's going to benefit from showing the connections. And that's not always going to be the entire enterprise warehouse. It's going to be, graphs should be built for a very specific problem. And so if you're looking at, customer churn or, the effect of your marketing efforts, you'll want very specific data in the graph designed to solve a problem.
We have another good question. What tools are used to convert structured data to the graph? And maybe talk about it. Maybe I'll throw it over to maybe Jon and then Philip to comment on this. Because you guys build out knowledge graphs, as I understand it. So you come into a client environment, you take a look at the systems that they have, and you help them build out a knowledge graph as the skeleton, if you will, onto which you can attach all of the myofascia, if you will. What do you think, Jon?
Yeah, look, I think it probably would be good just in structure to save that question because I think Philip's going to talk about GraphRag in a
Okay.
second, and then we can just walk through a real world example of how we built a system in a really large context, and then applications on top of that system and the connected structure within, in sort of a real life example, if that would help. I think
Yeah.
foundationally it'd be great to ground us, Philip, in what is GraphRag and why is it so important?
Yeah. Go
Cool.
ahead,
All
Philip.
right, let's go there.
All right.
All right, so we talked about Klarna earlier as an example. Like they've been a highly publicized early adopter and leader in Gen AI, and they're more impactful of their two applications, according to the CEO, is this internal application that serves up knowledge to, I think their monthly active user rate across their employee base is something like 90%. And it's used to answer any question about anything, really. So you can see some pretty impactful statements here. Yes, we did shut down Salesforce a year ago. We may have as many as internal estimate is around 1,200 SaaS applications were shut down. Part of their inspiration was actually Wikipedia
Hmm.
and saying that Wikipedia is one single source of knowledge for everyone in the world. And if you think about a Gen AI application, you want it to be able to have at its disposal any information inside the company so that it can make a better decision than, say, if you limit it to data in a particular silo, where you might get an okay decision, but then it's limited to that silo. And then if that silo is owned by someone else, then you also need to repatriate it if you want to build your own application. Um, so you can really look at the summary here is that they transformed um, their Gen AI application by going initially from LLM and then adding a vector database and then realizing, no, actually we need to repatriate the knowledge that we care about so that we can increase the scope of knowledge available to Gen AI applications and make it a benefit to the entire company. Knowledge graphs are popping up in lots of places. Here is Jensen talking about the three different kinds of data stores: vector database, structured data, effectively RDBMS, ERM, ERP, CRM, and then knowledge graphs. Gartner calls them the missing link between data and AI engineering. Forrester makes a similar statement last August on generative AI and knowledge graphs being a match made in heaven. There's a lot of complementarity here. So why is that? Well, the moment ChatGPT came out, it looked like we were going to have a hockey stick moment. And in some respects, it has been a hockey stick. But what everyone probably on this call quickly realized is as far as using just an LLM for your enterprise application, you run into this barrier. And you're not able to get to production. And that barrier is the result of a handful of limitations that are just showstoppers in the enterprise. Any one of these is a showstopper for an enterprise application. Having knowledge about your specific domain, ethical and bias concerns, access to the most recent data, not just data dating back to when the model was last trained or fine-tuned, inability to verify answers. This is the explainability point that Daniel demonstrated really well. And then privacy and security challenges, including the inability to restrict what data is made available to what user for what end use. Now, vectors raise the bar, but it's not enough. And even in a world where we're using vectors, despite all of the sizable opportunity that any analyst or financial firm will predict is available thanks to GenAI, somewhere around 70% of use cases are stuck in pilots. So what's next beyond LLM, small models, big models, fine-tuning, vector-based RAG? And here we're saying this is where graph RAG really fits and breaks through this going to production barrier. This is what we're seeing at Klarna. This is what we're seeing across many customers and many of data²'s and Neo4j's customers jointly. If I zoom down into the impact radar for generative AI, earlier you saw one that was just generalized across the entire tech ecosystem. For GenAI, again, knowledge graphs are right at the center alongside GenAI-enabled virtual assistants. So again, you're on the right call here. And this other prediction that by the end of this year, half of generative AI applications will use foundation models with knowledge graphs for improved reliability and transparency, which are key benefits. All right, so we've been talking about graph RAG. What is it actually? Let's give a definition here, and it's a simple one, simply saying that it's retrieval-augmented generation, where somewhere along the retrieval path, you access a knowledge graph. This leads to many different kinds of patterns. Let's talk about the key one, which is you do a vector search, find an initial set of nodes, traverse the graphs around those nodes to add context, and then you can even do things like rank the results using a graph algorithm like PageRank, and pass the top documents to the LM as ranked by the graph and filtered by the graph. That's the most common one, but there are many others. Another one is for more complex queries. You saw supply chain earlier. Eric made the comment that why use a very expensive and slow answer approximation model to get an answer that may or may not be correct for high stakes applications, when in fact certain questions are well answered in an exact and explainable fashion by a graph, such as supply chain risk, which is multi-levels and it involves math. So the secondary graph pattern is, well, I'm just going to delegate questions that I know can be answered better in a graph by graph query to the graph as a graph query, and then send that back to the LM and pass it through. So those are two of the top patterns. There are quite a few. If you go to graphrag.com, you'll see 10 or so emerging patterns, and we're adding to those regularly.
Yeah, and let me chime in real quick here, Philip. A lot of the work that you see around RAG, it seems to me, even these what model context protocols, isn't that what they're calling them now?
Yep.
MCPs or
CP,
something?
yeah.
Model
Big
context,
topic.
another big, very exciting thing. It could be, but that's all on the front end. So basically, that's adding context to push into the large language model, which you then get something back out. Okay, that's fine. On the way back, strikes me as almost more important than going on the way in, because on the way back, if you're careful, you can route it back through a graph, for example, or a structure, and basically vet some of the citations, do some work. There is a company doing work similar to that. We've had him on the show, Amar Awadallah. He's now with Vectara. He was with Cloudera, one of the founding members years ago. And that's what they just have a separate model in the end to kind of double check and do quality assurance. But it seems to me to come back around the other side and do a lot of stuff you're talking about with GraphRag, that's where you're really going to fine tune and weed out those last little outliers of hallucinations. Is that about right, Philip?
Yeah, what MCP does is it gives you the option to not only make a graph call alongside your LLM call, but to have your LLM make a graph call by effectively through MCP. So surfacing an MCP service as effectively a tool that can be called by the LLM, and then telling it that,
Oh,
hey,
wow.
you can call a graph, whenever you have supply chain risk come up as a question, just go call the graph and take and use that answer. So that has actually exploded the optionality if you think about, wow, what can I do when my LLM can suddenly access the graph?
Well, so this is actually very interesting, and let's face it, there's not transparency right now. Like you figure OpenAI is not open anymore. I joke it should be called closed AI because it's not open anymore. It was open source, now it's not. So you can't really see, but through MCP, are we actually then able to better understand the layers of the large language models, or is it just that you're allowing the LLM to do the graph call into your environment to help itself make a better answer?
Yeah, so reasoning models open up the door for having a set of steps and then being able to decide along the reasoning path, and I'll
Hmm.
put reasoning in quotes maybe, where to call the graph and what tool to use.
Very
Yeah,
interesting.
where this really helps is going to be around what information was brought in to uh, provide the answer. So what information was provided to the model when it was, deciding, hey, which suppliers were affected by this malware event. And so, that's where you're getting transparency on what data was accessed and how it was used by the model, combined with, as Philip mentioned, the reasoning capabilities of the model. So you are getting much more transparency than we had 12, 18 months ago. And really, what also helps there is the graph is putting the pieces of the puzzle together. Like one of the analogies I've used quite a bit is if you have a box of 500 puzzle pieces, think of those as 500 pieces of information. With just vectors, I'm dumping that puzzle out on the table, hiding the cover, and telling the language model, put it all together, and then cross your fingers and tell me what's in the picture. You know your data a lot better than the language model does. And so what we can do with graphs is instead of just dumping the puzzle out on the table, we can actually put all the pieces together, show the final accurate picture to the language model and say, okay, tell me what's going on in this picture, analyze this picture. I don't need to spend time and compute hoping that the LLM puts the pieces together. The graph and the benefits of graph RAG put those pieces together for the language model so it can focus on a very accurate picture of all the data that you might be brought together. And that's really kind of what we're seeing. And as Philip mentioned, MCP is making calls to a language model so much easier than before, so that we can get a much more complete, much more accurate view of your proprietary data. So
Hmm. I'm
hope
bringing
that.
this up again just as a graphic, but someone's going to chime in. Go ahead.
I was gonna, yeah, I know Philip had a few more of the benefits. We can talk about this, and then I want to make sure Philip, because there's a lot more benefits as well. I want to make sure we get to those too.
Okay, yeah, Philip, go ahead.
Oh, sure. Let me go do that. Uh,
And folks, you have great questions here. If we don't get to your question, I will pass this on to our friends as he's bringing up
Maybe
his.
do a question while I'm
Yeah, yeah, yeah.
figuring out.
So preferred toolkit for graph RAG pipelines for general purpose, complex, unstructured files at source like PDF, TIFF, PNG, all that kind of stuff. Any thoughts, maybe Daniel, on preferred toolkit for graph RAG pipelines?
Or actually,
Yeah,
Daniel, before
go
you
ahead.
answer the specifics on unstructured data, which is the way the question came in,
Mhm.
let me zoom out and highlight again the fact that you have in a graph, you can have structured and or unstructured data.
Hmm.
And actually, the two, it's best to have unstructured data come in when you have some structure to attach it to. And it turns out if, let's say you're bringing in service records for, machinery that's being serviced, and you want to do entity extraction from the text in the service records, the LLM, or even if you use a small model, it may not know what the component names are of your products or the names of the suppliers and what those mean. So chances are if you're dealing with those parts and those suppliers, you've got it somewhere in your company. It's probably in a, spreadsheet or more likely a relational database. You can source that in, and then you can refer to that as part of your unstructured entity extraction. So, uh, key point there is structured and or unstructured, but most often it's both. And then yeah, so, and Daniel, I'll hand over to you, and then we can come back to this.
Yeah, it's really, completely agree with everything Philip said. And that's actually a great order to bring data into the graph. As far as specific components or tools, it really depends on your environment. Obviously, we've built some components into our platform that we are very excited and very happy with, but we also partner with a lot of tools because we want to make sure whatever our customers have, we're able to work with. And some of our customers are cloud hosted. Many of them are self-hosted on-prem, which means different tools are available for different environments, especially when you get into the federal space. And so this is an answer that's a little bit of a non-answer, but I would just try out some tools that would be appropriate for your environment. And with the capabilities of the language models and just the maturity of the overall space, we have no shortage of very high quality pipelining tools to extract data from a PDF or parse out a text file or a markdown file. There's a lot of really good tools out there, especially compared to 2 years ago when there might have only been one or two.
Including even things like LangChain, Llama Index, Haystack, Unstructured just added a component. Neo4j's got a variety of tools. It's a pretty rich and fast-growing space on the unstructured side. On the structured side, it's a pretty well-known, well-trodden path to take relational data and translate it into a graph. So lots of tools around there, and the ISO standard I mentioned even includes some standard rules which the tools embody.
I'd say, just as a casual plug here, if you're worried about it or you have any questions about it, we can answer those questions for you. So if you have any questions about how to onboard it, how to create a graph, how to make that a reality, call us. We're happy to help you make that a reality.
Jon and Daniel are all over
Yeah.
that.
Yeah.
That's why John's the CEO, that's for sure.
Yeah, right. Well, here's another really interesting question from an attendee. Have you guys used Neo4j for live RAGs with live data streams like Kafka or Pulsar or Flink or something like that?
Yeah, let me answer that first more generally, and then we can talk about data squared. But I saw two heads nodding, so that's a yes, right? But thanks for asking the question, because the earlier question around like what kind of analytics you can do speaks to the human in front of a keyboard asking a question kind of use case, which is, let's call it ad hoc analytics, which very much is one use. But actually, the majority of Neo4j use is backing an application that is 24/7 behind a website. You don't know there's a graph there. It's doing these complex calculations and hosting your digital twin or doing cybersecurity, threat detection, etc. So you've got both worlds covered, and uniquely, you can actually start with one and add the other, or vice versa. You can actually do even both in the same system, which is by using like dedicated read replicas for analytics, while your right part of a cluster will handle high volume read write 24/7 transactional OLTP type workloads. Um, and so and in that world, you usually have, thousands of, or hundreds of thousands of transactions per second in the high end, um, coming in, maybe bulk loads periodically where you have millions per second coming in on a daily basis, data streaming in through Kafka, streaming out through change data capture. So Neo4j very much is happy to live in these kinds of transactional environments. So you have a lot of optionality. Also, fine on the back end of we were just making an announcement today, and my colleague was speaking at the Microsoft Fabric conference. On the back of a Microsoft Fabric or a Google BigQuery or Snowflake or Databricks, pretty common use case as well.
That's fascinating stuff. We got a couple more questions here. Let's see and by the way, yes, folks, we do archive all these webinars for later viewing, and we will post this onto YouTube as well after the show. So all that is coming for sure. Someone is asking for, like, right now you've already kind of talked about this a little bit, but maybe another example of real world examples where you're bringing in structured data, unstructured data, and you're affecting a business workflow. John, go ahead.
I was gonna say I'm
Yeah,
gonna
let's
nominate
go.
John for this.
Yeah, let's go ahead and jump into a real world example. So I'll try to share my screen. You guys let me know if you can see it or when you can see it.
Yep,
Are
I see it.
we look?
Good to go.
All right. You can see the Civitas screen here.
Yep, it's
Yes.
clear.
Perfect. All right. So real world example. We started working with a company that picked up, I think it was between 5 and 8 companies over the course of 2 years, and they wanted to integrate a bunch of differentiated data. That data set in boxes, it's set in files that hadn't been scanned, so we had to scan a bunch of data. There was a bunch of digital files, and it really scanned sort of an entire landscape of, hey, what functional groups are represented? What do we know about these assets? How can we ascertain at a high level what these assets are and what we can do with them? But the first question they asked us is, we picked up some midstream assets and we really want to understand how to optimize our disposal activities, reduce our total expense, and increase our profit potential on these assets because this is a new business opportunity for us. Now, anybody that knows anything about oil and gas knows that that's a really nuanced question. That's just not something that you can answer with a single repository of information. It's a multifunctional, collaborative piece of work to try to define how to do that at scale. And we built a system around doing sort of exactly that. So again, like, we built this as a strategic thought partner at a high level. Now, we integrated roughly 1,862 new assets that they had purchased, and we tried to answer this question. How can we optimize our disposal, reduce our expense, and increase our profitability? Now, at a high level, we need a lot of differentiated data to do that, but we built a strategic thought partner. And again, you'll see all of these source nodes and references, and I'll show you what that looks like in a moment. But something that can look at the entire picture simultaneously, something that can scan the entire value chain and understand, not just from a functional perspective, but from a business and a bottom line perspective, how we create value as a company, where our weaknesses are, where our strengths are, what our contracts say, and started to create a tool that you could use to not only understand the new assets that you picked up, but understand how to operate them more effectively for the overall business objective of making money. And ultimately, we had to ensure that we integrated a lot of multifunctional data, but we had to ensure that the fact base was correct. There was a question that was in the Q&A, and it was like, well, how can you, nodal references are nice, but like, how can you validate what you're getting? There's a couple of workflows there, right? Whenever we ask a question of a large language model, we're really sort of traversing what are very large pieces of information within a larger data universe that's contextually relevant to the thing that we're trying to define. And graph data science helps us get there. Traditional data science helps us get there. But it's really about retrieving the right pieces of that puzzle so that we can, at any point, understand what's important within the context of the question that was asked. Now, Dan showed nodal references earlier. That's nice, but at the end of the day, this is presented in this format so that you can see all of the different pieces of the puzzle that are being recalled simultaneously from each one of these nodes that are embedded semantically and connected across the data universe to give you the answer that was provided above. Now, this is a mix of internal information and open source information. Luckily, this is a heavily regulated industry. This is all public data, so I'm not showing you anything I shouldn't be showing you. But at the end of the day, the flexibility to sort of use both of these sort of internal sources and external sources, open source information to supplement your understanding of the assets that you picked up, allows you to do some interesting things and some fun things. So to do that, we had to combine all the wells performance information, all the saltwater disposal wells information, the history of performance on those assets, the drilling and completion schedule itself, our production forecast, our well water forecast, our historic water delivery and the efficiency that we got out of that system, the permits from the state. What does the permit say we can do with these assets, and how can we understand that at a fundamental level and connect that to a value chain optimization play? understanding our costs that are in, the agreements that we have in place commercially. Like there's different levers in each one of these agreements. They're all part of the puzzle. The infrastructure that's in place, all of our pipelines, all of our gathering stations, all of our surface facilities that we're using to connect all of these different 1,800 assets. To answer that one question, that highly nuanced question, you need about 7 different functions of information. It's targeted information, but you need multimodal information. So we're looking at structured, unstructured, semi-structured, transactional frequency data, and we're trying to build an ecosystem that we can operate within. And to do that, that's a non-trivial thing. It's about 5.5 million points of data to answer that one question. Like, how do we optimize our disposal activities, reduce our expense, and increase our profit potential? Now, when we deploy these things, we can get to the value in just a second, but because of the way we build them, I mentioned earlier, we define the who's, the what's, the when's, the where's associated to everything, and then we test everything within the structure of that model against each other to define the connections so that we can ascertain the whys and the hows. Well, in doing that, we start to build this ultra contextualized reality within a graphical context. And so when we do recall, we can do that on a semantic basis. And it allows us the opportunity to do really interesting things like perspective modeling and scenario modeling within the structure of these environments. So what we're showing right now is one of the questions we were asked from Civitas. Hey, we just purchased these assets. We don't know anything sort of in a micro context. We understand the top line, what they contribute, the dollars, but let's talk about the individual assets. Can you tell me from the perspective of a drilling engineer exactly what I need to know about these wells? And so what you'll see here is sort of an overview of the asset history, the depths, geometry, the well construction, the completion details, the technical analysis for wellbore placement is 100% end zone. You know, all of these things that are really important from an engineering context are sort of recalled. And then you have the ability to dive in through that context as an engineer to start to engage the data on that basis. But we also deal with things like accountants. And, you know, accountants are a huge part of how oil and gas companies like work on a day-to-day basis. The transactional density in these spaces are vastly different. So we needed to make a tool that could use the same integrated repository of information to answer questions that are geared towards the persona that we're trying to actually answer the questions to. And so this gives us a completely different view of this environment. It tells us what our financial metrics are, the production statistics, the well economics, the peak efficiencies, when we produce the well, what the economic assessment is, and some of the strengths and considerations for managing this asset forward. So from an accountancy perspective, from an asset management perspective, we can dive in on that basis. And it's because of the way that we build these models. They are inherently multimodal in nature. They allow us the ability to traverse complex relationships to find contextually relevant information, recall that information on query in natural language, and then present it to a large language model so that we can reason to and through it. Now, how that works in practical application is we know what we recall from the system. We know what we show to a large language model. We know what is returned from a large language model. We know the fact basis of those returns because we know what we provided it. And we know whether or not there's any hallucinated materials in the answers. And then we use human in the loop reinforcement to understand the value contribution of the answers that were provided. So we can go in and check the value. Did we recall the right pieces of the puzzle whenever we ask this question, and reinforce those relationships that are value adding to answering those questions within this problem context? And that allows us to do some very, very interesting things. And I'll jump into 2 applications, but scenario modeling at scale is one of them. And document reasoning or contextual reasoning across documents led us to an accountancy workflow that we'll talk about really quickly. So let me jump into this. I'll just go ahead and say, just like everybody else, this is all synthetic data. These are sort of real companies in context, but everything else you'll see is fake, and it's for the purposes of this demo. So if we wanted to help the accountants and our analysts within our financial units as an oil company answer how to route cost effectively to the right AFEs, the right cost centers, and then reconcile it against the contracts that we've signed and the requirements there within. Like, what do we need to do to figure that out? Well, the first thing we'd need to do is aggregate all of our well counting information. We'd need to be able to understand, the AFEs, the battery names, the pads, the cost centers, the pad names, who worked on it, when they worked on it, where they were. All of these things are really important. Which asset hierarchy are we operating in? The vendors, the supplier numbers, the historical codes that they have charged on, the historical locations they worked on, the historical phases they worked on, the cost centers that they're allowed to charge on. At a sort of more general level, what our pads are that are active right now, what our AFEs are that are active right now, what phase do they fall into? We also need to understand the wells basis we're operating from, and we need to understand from a chart of accounts perspective how all of these costs get routed across these different systems at different phases. And then there's sort of the bespoke area of this, which is the instructions that we can provide to the system to reinforce how we operate within this workflow. And so this all happens because we have the ability to work across what is a graph and what is a traditional database model and connect these two universes. We have something that's persistent and ever present in a graph that we use to reason to and through. And we do targeted recall on what is sort of a traditional database model and pull out when we need the targeted pieces of information that we need to supplement anything that we're doing from a graph perspective. So we can start to get really granular about detailed instructions for if you see this, even though within structure it should be routed in this direction, we know historically that the cost has been reconciled in this manner. Any rules about how certain suppliers should be treated at certain times of the year, any bonus or malus provisions, the ability to sort of take that entire workflow and take it from what is a very disaggregated, bifurcated information sort of space and bring it into a unified universal data model, and then start to use these tools, what they're great at, what they're great for, to answer questions, creates value. And at the end of the day, we can get to a point very quickly where we can load up an invoice and we can ask a system, hey, tell me what you know about this invoice, where I should code this based on what you understand from the recall, and then tell me how I should sort of manage the expense at current. And so what we do is we're using AI for what it's good at. It's good at understanding language. It's good at understanding connections in language if you can feed it those connections. And we're defining, not with 100% certainty here, we're not telling the people, this is exactly how you need to do it. We're allowing them to operate from a very narrow chamber of information that's relevant to the thing that they're trying to solve. So we're taking this universe of information, these like 6 million points of data across this graph, and we're distilling it down to its constituent parts that are relative to the query that we just ran, and telling people, we think these are the right things that you should be focusing on. But more important than that is we're telling them why. And whenever we look at this, we're generating descriptions of the invoice that we're seeing, the wells that they're on, the vendor, what phase it was in, the AFE numbers, the invoice name, the operations, the contracting type from a procurement perspective. All of these sort of information points allow us to triangulate from a costing and a treatment perspective where these things need to go. And so what this did in practical application is we built this application on top of the other piece of data that I showed you before, right? Which is this big universe of data associated to all of these operations across Texas and New Mexico. And we built an application in about 6 weeks and started to pilot test it. And we defined that within structure, there's probably an error rate of around 3.9%, which equates to about $9 million in misallocated, misapproved, or misaligned cost that had previously been reconciled through the system. So we're trying to take this workflow, which in this system, because it's so disaggregated and so messy an environment, normally takes somebody between 10 and 30 days to reconcile a single invoice. Just think, they're doing 10,000 transactions a day. Jeez. So a single invoice, 10 to 30 days. So let's call it an average of 20. And we're taking that entire workflow down to 2 minutes. So the intangible value creation for the people that are doing this work is exponential. Like Philip talked about the hockey stick. We're really delivering the ability to start focusing on the things that matter and not wasting a ton of time on the things that don't. And so this is really about augmenting people's capacity. This is not about replacing people. This is about creating better outcomes with machines and humans working together. And so we're trying to create solutions that help people be more effective, increase their capacity, and increase their capability. And this is a great example. And just this simple little application that we threw on top of this that was made possible by graphs has already created roughly $9 million of value. And as we scale that out to a broader set of work, we fully assume that it's going to create more. But that's just like one piece of the puzzle, right? The second thing that we did, I think that's sort of really important, is we built a tool which allows us to scenario model production facilities, our handling capacity on surface, how we treat water, how we dispose of water, how we do that on an economic basis, and how we handle any overages in the system at scale. And so what we're looking at here is an ability to, and on an objective function basis, clarify how to operate most efficiently in the day on a day-to-day basis, but more importantly, in a strategic construct, how can I design my wells, my facilities, my infrastructure at the lowest minimum cost to meet all of the upside that we could potentially capture from these assets. And so I'll walk you through this very, very quickly. But at the end of the day, what you're trying to do is compare different alternatives. And what you're saying here is we have alternative one, a pipeline connection, direct disposal, and frac tanks for holding the delta at the top. And over here, we have two disposal wells, we have no pipeline, we have a frac tank, and we have trucking. And so these are two vastly sort of different approaches to handling production and water within the structure of a producing oil and gas field. Now, we start from sort of the similar basis of give me all the wells, tell me everything you can about them, give me all the batteries, give me all the production forecasts, give me the disposal options, tell me what those are, water storage options. And then we built a system around a unified graph data model, which allows us to say at any point in time, over any range of time and any range of wells, how we can treat these things on the lowest economic basis. And so whenever we start to look at this, we have different options. Some are piped, some are not. This is the thing that you could sort of build in practical application in a planning phase to say, do I install a pipeline at a certain dollar per foot or dollar per mile? Do I like build a frac pond that is going to cost, anywhere between $2 and $5 million plus any of the remediation cost associated to it when evaluating these options? But you can start to select these things. And then you can look at your storage options. And again, this is just an example. You could build a library out of all of your storage options, all of your cost alternatives, all of your minimum fixed and variable costs associated to these things, and model all of those things simultaneously. You could figure out what is the best from a linear programming perspective alternative for how I can minimize risk, but still meet my objectives at the lowest cost function. So when you do this, you'll run a scenario. We can look at sort of the trucking. This will take a few seconds to run, but you have the ability to clearly see how alternatives and at any point sort of contingencies could manifest themselves and what that's going to cost you and what it's going to earn you at the end of the day. And so we're trying to use what is a unified data model to create an opportunity to do fairly transcendent things that traditional relational database models, even in an engineered capacity, are not even remotely close to doing without building some of the most intricate like Excel calculators that you would ever see. And so we're really trying to make this easy for everybody. When we push this out to production superintendents, we can see, hey, on a cost basis, like we're looking at a couple of different alternatives. We're going to dispose in these assets. We have these wells. If we're going to do trucking only, we know that on this day we need to handle 53,000 barrels, and we need to do it from these quantities from these wells on each one of these days. And we understand exactly where they're coming from and how we're calculating that basis. But at a top line, we can understand, hey, in this instance, this mix of different alternatives created an opportunity for, $1.7 million of cost that I need to outlay to manage these assets effectively. And we can quickly compare, whether or not these two things make sense in context. So again, we're starting from a universe of information. We're harmonizing this universe of information. We're creating the opportunity to understand how it's connected, why it's connected, and what it means for us as the owners of this information. And then starting to deploy applications on top of this information repository that are targeted in nature, that allow us to traverse really complex relationships and find contextually relevant information quickly and across information domains that are inherently disconnected. And that's probably the most important thing, is we don't need a data lake this stuff. What you see here is a
Right.
representation of information that is connected. These are persistently connected information pieces in the repositories they exist in now. And so that's why it's so important to kind of show people data in its native form. Now, we do create a graph and we use a graph, but this is so important. It's that connective tissue, as Dan talked about earlier. It's one of my favorite things to say because it's so real. Those connections matter. And we like to say to people, you're not missing data. You're missing the connections that matter within the data you already have.
Mm,
And if we can start
wow.
to think about that in that context, we can start to re-envision how we want to use information. And
Wow.
that really starts to open the door for value creation. In these instances, these two products together, these two applications have created roughly around $30 million of value in a year. So we're not talking about, potential. We're not talking about something that might be valuable. We're talking about something that's creating value on critical path right now in one of the most information heavy, disconnected, bifurcated, operated pieces of industry in the world today. And so
Wow.
it's really transformative stuff, but it starts and ends with the ability to get that information into a unified, harmonized data model. And to Philip's earlier point, the only one I know of that allows us to combine structured, semi-structured, unstructured, transactional data is a graph. And that's why we anchor on it. And that's why Neo4j is so, so important to everything that we're doing as a company. Is such a great partner for us.
That was absolutely fantastic. And what you're also able to do here is enable real-time, dynamic, bespoke Monte Carlo assessments, basically, and
That's right.
then compare and contrast. And then think about, from a risk mitigation perspective, you're able to do these very complex scenario modeling situations and then present that to the board or present that to the auditors as they come on. Well, why did you do this? Well, this is why. Like,
Mhm.
what? Like, to think
Yeah.
about the time it would take to have someone write a report like that. It could take weeks. It could take, 2 months.
Years,
It could take
years.
years. Instead, you're dynamically generating that based upon existing text, existing documents, existing transactions in a real world environment. I mean, it's just like a real time, on demand, multimodal data warehouse like analysis scenario. Just boom. That's
Yes. And
crazy.
look, in the industries we're operating in, and Philip knows this really well, primarily defense, intelligence, and engineering. Now, this it flows over to healthcare, people, and finance, but these are high reliability industries. The cost of failure is exceptionally high. Our
Right.
ability to generate systems that allow us to get down to the data record level citations associated to how answers were generated and be able to see that full chain of cognition and validate
Right.
through human inference exactly how that chain of cognition was executed and whether or not it's valid
Right.
is vitally important. It's almost an imperative to the point that we can't scale these tools in these industries without that as a fundamental part of what we offer. And that's
Wow.
really where graphs start to unlock the ability to do that very specifically.
Yeah, you had this one, I actually posted this already, but you had a lot of great quotes. One that just jumped out at me was, well, in doing that, we start to build this ultra contextualized reality within a graphical context. Yep, that's what you're doing. Closing comments, Philip Rathle.
Digital twin of the real world is what I just heard.
Yeah.
Yes, sir.
That's good stuff. Closing comments from Daniel Bukowski.
Really, at the end of the day, it's connecting the dots. And John and Philip have both said this, but you have your data. The connections already exist in your data. The problem is you're just missing those connections. And that's what we're trying to do with data² and Review. That's what Neo4j is building with the Neo4j graph database. It's just connecting the dots in your data.
Right.
And by
Right.
connecting those dots, you're going to unlock a whole new world of insights, both for you and for the language models that we're slowly moving into adoption. And it's not just the insights, but it's also the transparency around how we're coming to specific answers, how we're getting to the information, how it's being used. And that's what's so critically important for not just any production use of AI, but like the high reliability where, as John said, the price of failure is so exceptionally high that you need that accuracy and transparency. And we really believe graphs are the way to do this.
Hmm. Well, you're providing this contextualized worldview that enables any kind of discovery or analysis and reporting, dynamic reporting that gives great detail into what went into this decision, how you got there, what the end results could be. And of course, you can track that over time and do these various things. And I'm going to close with one of the great quotes I heard over 17 years of doing these shows. Someone once joked, yeah, in the IT world, we always think one more layer of abstraction can solve all our problems. Well, in this case, I think it kind of can, simply because
Yeah.
you are creating this connection to all these different environments, including large language models, by the way. So, including being able to leverage the power of these multi-billion-dollar engines that are being constructed, and then tempering them and harnessing them, because that's what you got to do, right? That is bringing it all together again. I'm reminded of another fun quote. I wrote my thesis on this in college in my philosophy class on deconstruction. Edward Albee, in his play The Zoo Story, had this great line. He said, sometimes it is necessary to go a long distance out of the way in order to come back a short distance correctly. And I feel
That's
like
right.
that's what you guys have done.
It's a great happy medium between let's centralize absolutely all the data and connect every single application in the company to one source of truth, which doesn't work for a whole bunch of reasons.
Right.
And at the other extreme, let's federate absolutely everything and not centralize everything. Anything that also doesn't work. Here with a graph, you can choose, let's bring hooks in and pointers to other data sources along with the data that I need in order to filter, traverse, run my graph queries. So you're somewhere in between in exactly the place that enables all this analytic and transactional capability for AI, which AI needs.
Yep.
That's right. It's
I just want to,
synthesis. Go ahead.
can I do a quick PSA?
Yeah, yeah.
I just want people to understand. Like, we didn't choose graphs because they were neat. We chose them because they unlock the ability to do things that you can't do with relational databases. Full stop. And this applies to sort of any method of retrieval, tagging, semantically embedding, creating joins in any sort of relational context. When you use those systems, they're inherently disconnected. And you can come up with sort of very temporary ways through chain of thought prompting and other things to create a contextual awareness in some connected synthetic version of reality, but they're ephemeral in nature. So we chose graphs because we found out early that they are the unlock for reducing hallucinations and increasing efficacy in application from generative AI. And it's the only thing that we have found that is persistent at this point in time. So if you talk to somebody and they say, with your relational database, we can take an ontology only approach and we can start to create outcomes that are going to aid in generative AI's capacity to scale. That's not really true. And it's not true right now because of the fundamental architectural limitations of these systems. It's not true right now because of the way that you have to manually engineer those outcomes and maintain them over time.
Right.
It's not true because you don't have depth and consistency in how things are coded and tagged and embedded within models. And those three things are really non-starters to scale. So when somebody comes to you and says, we are going to scale generative AI solutions in your business, taking a relational database model and coming up with some of these sort of ephemeral ways to change the way that you see the world and that large language models see it, just know that your cost is going to be so exorbitant over time that it'll actually detract from value. And now that may change tomorrow. There may be a technology and an innovation that happens tomorrow that changes the way that we see this world and the way that we read sort of the tea leaves as they are today. But as of today, if you're looking for scale generative AI solutions and you want to deploy those internally, like Klarna, to the effect that Klarna had working with Neo4j, graphs are where you start. And you can give Neo4j a call and you can give us a call and we can help you get there. So that's just a PSA in general. Don't waste time trying to rewrite the world or re-engineer it. Let's find a
Right.
better way forward. Let's find a more simplistic approach. Let's create some graphs for you. We can do that in an automated way and we can make your life easier and more effective with generative AI.
And with that, we're going to bid you farewell. This was a fantastic show. Big thanks to Jon Brewton and Daniel Bukowski of data². Big thanks to Philip Rathle of Neo4j. We do archive all these webinars for later viewing. Send me an email if you want to be on one of these shows, info@dmradio.biz. We'll talk to you next time. You've been listening to The Briefing Room.